Hello, I'm going to teach you how to answer questions to do with the particle model. So that's things like solids, liquids and gases, density, changes of state, kinetic theory. And these questions, there's 27 marks worth of questions. They've been taken from 4 different papers. So that means on average, each paper every year's got about 7 marks from this particular unit. And remember, 7 marks is a level, so every year you'll get about an extra level if you manage to do well on this particular topic. So let us help you answer the type of questions you're going to see. Question 1. A student uses the apparatus in figure 17 to determine the specific heat capacity of water. State the measurements needed to calculate the specific heat capacity of water. Well, as I say to my students, always base your explanation on the calculation. So what's the calculation with specific heat capacity in? Well, you'd find it at the back of the paper on the formula sheet. And it's energy equals mass times by specific heat capacity times by temperature change. E equals mc delta theta. Alright, so the measurements we need, we're going to need to measure mass, we're going to need to measure energy, and we're going to need to measure temperature change. Now that's 3 marks, but we need 4. So put a little bit of extra detail in for one of them, and I think the easiest way is to say the temperature change. You're going to need to measure the final temperature and the starting temperature. And that's how you'd get your 4 marks. Sometimes they ask you how are you going to take those measurements. So just in case that's the question this year, with the mass we'll use a balance or a mass top pan balance. To get the energy we'll use the joule meter. And for temperature change, well, just like any temperature, we'd use a thermometer. Okay. Part 2. State 2 ways that the apparatus could be adapted to improve the procedure. Okay, so let's have a little look and see what's going on. So we need to put energy into a mass of water and get the temperature change. Well, the energy is coming through the heater. Well, they haven't even got the heater fully submerged. So that's the first thing. Make sure that the heater is right under the water. Right, we're going to lose energy because they haven't got a lid on there. So put a lid on the beaker. Now the energy from the heater might not stay in the water because there's no lagging or insulation around the beaker. The thermometer is just in one spot, so what you could do is put a little stirrer in the bottom that spins round, little magnetic stirrer, so it'd have to be on like a little magnetic stirring machine, but don't worry about that, just say add a stirrer. And it was only worth 2 marks, and we've put 4 things there. So go with the easiest for you to remember. I tend to go with that one and that one. Question 2. A student determines the density of a liquid. The student puts an empty measuring cylinder on a balance. The student then adds liquid to the measuring cylinder. Calculate the mass of liquid added and the volume of liquid added. Use the information in figures 10A and 10B. Right, mass of liquid added. Okay, so it was 201 grams without any liquid in, and then it goes up to 230 grams with the liquid. So that'll be 29 grams. Right, the volume of liquid added, well, at first there was none, and then it's gone up to 25. So 25 centimetres cubed, that's right. Part 3. Which equation should the student use to calculate the density of the liquid? Well, density is mass divided by volume, so that's D. Part 4. State 2 improvements the student could make to this investigation. Right, so they've measured the mass. I mean, there's not even any decimal places there from the balance. So use a mass balance that has decimal places. And measuring the volume, I mean, it just jumps up in fives, doesn't it? So use a more precise measuring cylinder that goes up in ones or twos. Just going to change that a little bit. So use a more precise measuring cylinder that goes up in 1 centimetre cubed or 2 centimetre cubed at a time instead of 5 centimetres cubed. And it's only worth 2, so that'll do it. But if it was worth 3 or you didn't like any of those answers I've gave, I'd always say repeat and take an average. You have to say and take an average. They don't give you marks anymore for saying just take a repeat. Question 3. Figure 11 shows an electric kettle. The kettle contains 1.5 kilograms of water. Right, that's the mass. The kettle is switched on. Calculate the energy, so energy is our target, needed to raise the temperature of the water by 50 degrees C. So that's our change in temperature. And the specific heat capacity of water is 4,200 joules per kilogram degree C. So they'll always give you that, unless of course you've got to calculate it. So remember that the specific heat capacity of water is 4,200. Right, use this equation. So energy, or delta Q as they've said here, that is specifically heat energy. Q. E is just general energy, but Q is heat energy. Right, pop the numbers in. And pop that into your calculator. And the answer is 315,000 joules. Part 2. The amount of energy E needed to bring the water to boiling point is 670,000 joules. So there's E. The kettle has a power of 3,500 watts. That's P. Calculate the time it takes to bring the water to boiling point. Use the equation. Right, so we're going to need to rearrange that. So remember, if you're no good at rearranging, use a magic triangle. Draw a triangle, draw a divide by sign, and then draw a times by sign underneath it to create 3 little boxes. Right, is there something on the top shelf out here? Yes, okay, so it goes on the top shelf in here. And then 2 spaces and 2 things. Shove those things in those spaces. Right, cover up what you're looking for, and what you're left with is how to work it out. So we're looking for T, cover up T. We're left with E divided by P. So T must equal E divided by P. Pop the numbers in. The energy was 670,000 joules. The power was 3,500 watts. And that comes out as 191.42 seconds. Question 4. A digital thermometer gives you a temperature reading of 23 degrees C. Calculate the value of this temperature in Kelvin. Okay, so to get the temperature in Kelvin, you take the temperature in degrees C and you add 273 to it. So that's going to be 23 degrees C plus 273. That's going to come out as 296 Kelvin. Now, just in case they ask you to convert from Kelvin into degrees C, you'll need this equation as well. So the temperature in degrees C's is basically the temperature in kelvins take away 273. So make sure you know those two equations. It could be worth a mark for you in your exam. Question 5. The volume of 380 grams of ice is 410 centimetres cubed. So that's your mass and that's your volume. Calculate the density of the ice. So density is like a wiggly P. In grams per centimetre cubed. Right, always take note of the units. Because with a question like this, they'll often get you to convert from kilograms into grams or something like that. In this case though, they've already gave you the mass in grams and they gave you the volume in centimetres cubed, so it's pretty straightforward. That's why it's only worth 2 marks rather than 3. So density is mass divided by volume, so pop your numbers in. The mass was 380 grams. The volume was 410 centimetres cubed. Pop that in your calculator, and that equals 0.9268. If we round that up, that's just 0.93. Yeah, and I do like to put the units in. That's grams getting divided by centimetres cubed. So your unit is grams divided by centimetres cubed. And then just check that unit with the unit they wanted, just to make sure it's the same. By doing that, you can sometimes spot the fact that you may have forgot to convert maybe grams into kilograms, you know? Question 6. Another student decides to melt some ice. The student melts 380 grams of ice at 0 degrees C, so that's our mass. The specific latent heat of fusion of ice is 3.34 times 10 to the 5 joules per kilogram. Right, see? That's in grams, that's in kilograms, so we're going to have to convert that into kilograms. Calculate the thermal energy needed to melt the ice. Select an equation from the list of equations at the end of this paper. So the equation will be Q equals mL. So M times by L. So that's the mass times by the specific latent heat of fusion. So I'm just going to convert grams into kilograms first of all. So 380 grams divided by 1,000 grams in a kilogram, and that'll come out as 0.38 kilograms. So pop the numbers in, and that equals 126920, 126,920 joules. And make sure you know how to enter that kind of number into your calculator. Question 7. Solid, liquid and gas are states of matter. Which process describes the change from a solid to a liquid? Right, well make sure you know all the different changes of state, so if I'll draw them down here for you. Solid into a liquid's melting. Liquid into a gas is evaporating or boiling. Gas into a liquid's condensing. Liquid into a solid's freezing. Now, do you know what they call it when a solid turns into a gas without going into a liquid? That's called sublimation. And do you know what they call it when a gas turns into a solid without going into the liquid phase? That's deposition. Now for physics, you definitely need to know sublimation. Deposition, more of a chemistry thing. Right, so which process describes a change from a solid to a liquid? Solid to a liquid, that was melting. Question 8. The particles of a gas exert a pressure on the walls of a container. Which row of the table is correct when the pressure of the gas changes? Right, so if the pressure of the gas increases, the number of particles colliding with the walls of the container each second stays the same? No, that's not right. That should be increases as well. So pressure of a gas increases, number of collisions increases, correct. So your answer is B. I'll just check this. If the pressure of the gas goes down, the number of particles colliding with the wall stays the same? No. And if the pressure goes down, the number of particles, collisions increases? No. So the answer is definitely B. I've got a lovely little video on my YouTube channel all to do with pressure of gases and temperature, if you don't really know what's going on here. Question 9. Kinetic theory describes the movement of particles in the 3 states of matter. Gas is one of those states of matter. Name the other 2. Oh, how easy. Solid, liquid, gas. That's the 3 states of matter. Part 2. Complete the sentence by putting a cross in the box next to your answer. The average kinetic energy of the particles in a gas is directly proportional to... That'll be the temperature of the gas but measured in kelvins. So that's C. So you're supposed to know this graph. Average kinetic energy and temperature. But it's in kelvins. And the graph goes up like that. If you did the same graph, but with the temperature in degrees C, you'd need this back part of the graph here, and the graph goes like that. And this number here is minus 273, and that's what we call absolute zero. Absolute zero is the temperature in degrees C's when the average kinetic energy of the particles is nothing. Again, if you don't know anything about absolute zero, I've got a nice little video on my YouTube channel, check it out. Question 10. The student decides to measure the temperature of the water every minute while it's being heated. Figure 18 shows a graph of the student's results. Predict the temperature of the water if the heating continues up to 8 minutes. Right. Well, what they've done, 1, 2, 3, 4, 5, 6, they've got 6 results. Now, as I say to my students, why do we get 6 results? Well, because then we can spot a pattern. So by looking at these results, we can just continue until we get to 8 minutes. Now make sure that you take a ruler into the exam with you so you can draw a nice straight line. So at 8 minutes, if that heating trend was to continue, that pattern was to continue, it looks to me that it's 104. So make sure you know. So going from there to there is going from 100 to 110. So that's 10. And there are 5 little boxes. So each box is 2. So that to me looks like it's 104. Now the thing is I have actually looked on the mark scheme and it says accept any value between 95 and 102. Now I think that's too low, to be honest. From that line of best fit, there's no way you can make it any lower than that. And there we go, that's the last question. So I hope that's been useful. If you've got any other questions, just put some comments below and I'll get round to answering them for you. Good luck in your exams. Work hard and be nice.